Hello friends, I am Madhav Pani and I will be discussing on the project car price prediction, and this project is developed by me, and how I developed from the very basic till the deployment of the project in Hugging Face I will be discussing here. So let's start it. At first I have imported libraries like pandas for data manipulation, NumPy for numerical Python or numerical calculations, Matplotlib and Cbun for data visualization. And in second step or second cell, I have imported warnings of Python libraries, and warnings has a function filter warnings, which I have used it to filter the unwanted warnings or casual warnings. So let's execute this cell, and in third cell I have imported joblib. The joblib library is used to save and serialize the model. So let's execute it, and then I have loaded the dataset trueColListings.csv. The trueColListings.csv is downloaded from Keras platform, and it will be available on the repository, and I will be providing that in my description box. So I am using only 4 columns for this model building: price, the targeted column, mileage, make, model of the car is the required columns. So using pandas, we have a read CSV function which reads the CSV and converts and stores it as a data frame, and this I have stored in cars df, which means cars data frame. That is, the dataset is loaded into cars data frame, and dot head shows the first 3 rows of the data frame. So let's execute it. So see here we have price, mileage, make, model columns, and in price we have these 3 prices, and in mileage these 3 values, and who is the maker of the car. So all 3 are Acura and its models. So let's see some properties of the data frame, so that we will be understanding how many rows or how many columns are available, and what is the correlation between the columns that can be seen from the data frame properties. So let's go to execute it. So let's first see the shape of it. So see here guys, 8,52,122 rows are present with 4 columns. This is the shape of the data frame that is available with us. And let's see the columns of the data frame. So let's execute it. So see here, price, mileage, make and model. These are the 4 columns that we have with us. So let's calculate the correlation between only numerical columns. So we have a core function in pandas or in NumPy, and where numeric only will be selecting only the numerical columns from the data frame, and this function will calculate the correlation of numerical columns. So let's execute it. So see here guys, price and mileage, these are only the 2 numerical columns available with us in the data frame. So the correlation with price to price is 1, and with price to mileage is minus 0.421237. So let's get more information about the cars data frame. So here guys, this is a pandas function, and this will give this result. The info method will give this result. So here it is range index. It is showing that there are 8,52,122 entries, that means rows are available, and the index starts from 0 to 8,52,121. This is the last index. And how many columns are there? There are 4 columns, total 4 columns. See here guys, and here column names, and how many non-null values are available in second column, and in what are the data types. So we have 2 int 64 and 2 object type. So let's clean the data. So the next step of developing or building a data set, a machine learning model, is to clean the data. First thing is need to clean the data. We have to keep the model clean the data. So whenever you are cleaning, the first step of cleaning a dataset is to remove duplicates. So in pandas we have a method duplicated, which will show if the row is duplicated, it will be showing true, or else it will be showing false. And the sum, when we apply sum to it, it will show how many rows are duplicated, total number of rows. So let's run this cell. So see guys, we have 1008 rows duplicated in our data frame. So to remove these duplicates, we have a beautiful pandas function, drop duplicates. So we will be using drop duplicates, and whenever we set the parameter in place equal to true, it will with removing the duplicates from the data frame, it will be saving the same removed or cleaned data frame to the same variable. So for that reason I have used in place equal to true, and if the ignore index parameter equal to true, we don't need to reset the indices, because whenever we remove the duplicates, the indices doesn't follow the order, serial order. That's why when we do ignore index equal to true, the indices are rearranged. So let's execute it. Okay, fine. Now let's check what is the new shape of the cars data frame after removing the duplicates. So let's execute it. So we have now 8,51,114 rows and 4 columns. So guys, the next step of data cleaning is to remove nulls from the data frame, and let's see how many nulls are available in our cars data frame. So is null is a pandas function which will be showing if null value is present or not, and dot sum, when we apply it will calculate the total number of nulls present in each column. So let's execute. So see guys, price has 0, mileage has 0, and make has 0, and model has 0 null values. All the columns have 0 null values, so we don't need to remove any null values. So the next step of building a machine learning model is to visualize the data and find the important insights from the data visualizations. So the next step is, it is called EDA. EDA, the full form of it is exploratory data analysis. So we will look into the visualization and we will be finding more interesting insights from the visualization. So that is the main reason for which we are going with EDA. So at first, the price column. So price column, so I have already told you that for data visualization we use matplotlib library and seaborn library. So these two libraries are used to plot different plots of the columns. So let's see what are those plots, and let's see what are the visualizations we are getting from these plots. So at first, this plot. So SNS provides a method displot which will be a distribution plot. So this method has some parameter which it takes. Sorry guys, my English is not so perfect, please do cooperate and understand. So displot is a method in C1. It will take 3 to 4 parameters, but I have used only 3 parameters as per my requirement. And if you want more parameters, you can press Shift and Tab so that all the parameters will be listed in Jupyter Notebook. So no need to worry. Enter Shift Tab, so you will be seeing what are the arguments or parameters we need to pass it. So I am passing X as price, KD equal to true, and data equal to cars data frame. So it means that I am using price column for plotting and cars data frame to pass the data set, and KD. So KD equal to true. So plt.figure is to set the figure size. So I have set fig size equal to 12. That means the length of the row is 12 units, and 4 units as height, and plt.show is to show the plot. So let's get the visualization. So let's wait for a while because it's a huge data set and it will be taking too much time. Yes, we got the plot. So the KDE line is this blue, darkish blue line available in the plot. So if you set KDE equal to false, it won't be visible. This line won't be visible. So the next is hist plot. Hist plot will be plotting histogram of the price column and using cars data frame data. As usual, the plt.figure is to set the figure size and plt.show is to show the plot, and SNS has another function called hist plot, which will be plotting histograms of the columns that we provide to it. So it is taking x, that is the column, and data, that is the data set or data frame. So let's execute it. So see guys, we have this histogram plot and see the bars. So the next plot I have used is the blocks plot, which will show the outliers. If outliers are present, we can easily visualize through box plot. So this is for setting the size of the plot, and plt.show is to show the plot, and we have box plot method in Seaborn. It is also taking 2 parameters, and I have passed 2 parameters. It is not taking 2 parameters, it have multiple parameter list. You can so I have passed price column and cars df column, sorry, data from, sorry guys, my mistake. So let's run it. The next column is mileage. So as I've told, these 2 lines are for setting the size and showing the plot, and here I have used the distribution and hist plot and box plot as similarly. So sorry guys, I have not explained this plot. So these are the outliers, the darkish points and dot points. So see, we have too many outliers in this plot. Similarly, we will be getting the mileage distribution plot. Don't worry about the code, I have given it in, I have a repository. I will be providing that in the description. So see guys, distribution plot of mileage column. This is the histogram plot of mileage column, and this is the box plot of mileage column. See, in this box plot we have too many outliers, and which need to be removed whenever we, for the cleaning of dataset, means removing the outliers or clearing the outliers from the columns. So as this is a basic project, I am not going with that. Please ensure that you have to remove always the outliers. So the next column is make, the car maker. So I am just plotting a count plot, and I have in the first line I have setting the size of the figure or the plot, and x sticks are rotated to 90 degree. The count plot method takes many parameters, and I have used only 2 parameters, x, that is the column name, and data is cars data frame. So let's run it. So the next step of building a machine learning project is data pre-processing. So in data pre-processing, I have developed or built a column transformer. So column transformer is a class in scikit-learn compose module, and this class is used to transform all the columns that we need to transform simultaneously. So it will be handling, or it will be transforming all the columns that we pass to it. So basically it will take a list of tuples of transformers. So in tuples we have to provide three things. One is the name of the encoder, the second one is the encoder or the transformer. The first one is name of the transformer, the second one is the transformer object, and the third one is a list of columns. So see guys, I have used one hot encoding, and this is the object one hot encoder, and this is make and model. So to find one hot encoder or min max scalar ordinal encoder, it is in the pre-processing module of the scikit-learn. So one hot encoder, in one hot encoder I have used drop equal to first to drop the first column after pre-processing or after transforming, and handle unknowns equal to ignore the unknown values or unknown data, and sparse output equal to true. I personally set it into sparse output equal to true, because if we set sparse output equal to false, then it will allocate around 12 GB memory to the data, because already it's around 850,000 data points or rows we have with us. That's why sparse output equal to true is set into true. Sparse output is set into true. And make column and model column is these two columns are object or categorical columns. That's why I have used those two columns to do one hot encoding. Then the mileage column is, as mileage column is a numerical column, so I have implemented min max scaling to it, and if I set remainder equal to drop, then it will drop the last column, that is price column. Okay guys, let's let's run this cell. So see guys, this is the column transformer, one hot encoder, min max scalar, where all the outputs are coming to this way. So the next step of building a machine learning project is splitting the data into two parts: test, train set, and test set. So in scikit-learn we have a module called model selection, where we get a train, test, split, a beautiful method of scikit-learn which will split the data set that we provide into training and testing data as per the arguments passed to the method. So let's execute this cell, and in this cell I have allocated mileage make model of the data frame to x variable and price of the data frame to y variable, and I have going to see the shape of both the x and y variables. So see guys, 8,51,114,3 is the shape of x, and 8,51,114 rows is the shape of y. So train test split takes at least minimum required 3 parameters. Those are x or x data, y data, and test size or train size. These are three important and surely required parameters of the train test split method. So I have provided x, y and test size equal to 0.2. That is 20% of the data is my test size. And here random state equal to 3, and as per me I have set it into 3. You can set according to your wish, and if you change the random state, your result will be different from my result. So if you are going with me, and your result will be same with my result. So shuffle equal to true, it is to shuffle the data. So this method gives a tuple where we have 4 values. One is xtrain, the another is xtest, and another is ytest, and the last one is ytest. So xtrain, xtest, ytrain, ytest, these are the outputs of train test split. So let's run this cell and see the shape of the xtrain and ytrain. After pre-processing data, we have to build the model. So I am going with linear regression for this basic and small car price prediction project, and you can implement the same with random forest or decision tree regressor, a Cannon regressor, and many more things are available. You can try those things. And for this project and for this problem, I am going with the small or the basic linear regression approach. So the linear regression is available in linear model module of scikit-learn, and I am going with the pipeline approach because in production the pipeline approach is followed. So remember guys, always use the pipeline approach, or pipelining is important in productions and in daily lives. So the pipeline class is found in pipeline module of scikit-learn. So pipeline takes a single argument steps, that is list of pipelining steps. So first step is to pre-process the data, raw data, and the second step is linear regression. So steps is a list of tuples where each tuple takes 2 values. One is name of the pipeline object, that is column transformer, and the other one is the object. So let's run this cell and see the pipeline that we built. So see, the column transformer is the first step, and the second step is the linear regression. So here see, you are getting dotted lines, that is the first step, and the second step is linear regression. So after doing the pre-processing, we are providing the values to the linear regression model. That is the main important thing of this pipeline. So let's train the model and evaluate the model. So fit is a method which is used to train the pipeline. So fit takes 2 values or 2 parameters, xtrain and ytrain. So these are the training data. This is xtrain, this is ytrain training data. So let's run this cell and train the pipeline. So it is taking time because the dataset is very huge. So if the dataset is small, then this will be done within few seconds, but as it is a huge dataset of containing 8,51,000 values, that's why it took more time than expected or more time than what it takes. So the pipeline is trained. So let's test, or let's evaluate with score the built-in function of every estimator. Estimator is that nothing but linear regression model that I told, or that this is called estimator, a linear regression. These are called estimators in scikit-learn language. So score is the built-in function of the estimator linear regression, and it takes two parameters, unseen data. Let's execute this cell and see the value. It is giving 81% of accuracy in our project. So as model is already successfully built, now model saving. So save this model to use it in Streamlit app or in deployment field. So to save the model, I have told you that we will be using the job leave. So what are the objects that we need to save for use of this? So what are the things that I need? I have stored in a dictionary, and I am sending the dictionary or saving the dictionary to as data.joblib. So from this line of code, I am assigning all the car makers to x variable. So let's save all the list of car makers to x variable. So the unique will give a list of unique values present in the column of the data frame. So let's run this cell, and in this few lines of code, I have created an empty dictionary and iterating from the first to the last car makers, and in each car maker I am trying to find the models that are available with each car maker and saving in models, and those models are appended to the car makers dictionary or models with respect to makers empty dictionary. And that's what I have done, and let's print it to see. So here Acura maker has these many models in its it is developing with. So the job lead, the next part is to create the data to save. Sorry guys, I have written here send. It is not send, it is save. So data to save. So I am saving my pipeline, and I am saving this entire dictionary. So models with their makers dictionary. So let's run this line, and joblib has dump method which takes two values. One is the object which need to be saved, and another is the name of the file in which we are going to save the data. So data.joblib, you can create any file name, that's not important. I have saved it to data.joblib. You can create data.pickle also, or data.html also, whatever you like. I am saving in data.joblib file. So let's run it. So successfully we have created the model and saved it. Second part of car price prediction. Now that is the second part of car price prediction is building the front end. That is how the users can use our project or my project. So I am building it through Streamlit. Streamlit is a beautiful library which helps us to deploy our projects within minutes, and it supports machine learning, deep learning, and artificial intelligence as well. So let's start our how I built this front end part. So at first I have imported the libraries like Streamlit, NumPy, Pandas, and Joblib, and I hope you know Streamlit is used for building the front end part, and NumPy and Pandas are for data manipulation and data calculation, and Joblib is to load the saved model. Previously we have saved the model using the Joblib, and now we will load the model again using the Joblib. So loading the model, the next part is loading the model. So in data variable I am storing joblib.load the data that I saved, and the file name is data.joblib, and after loading the data I'm passing a key pipe. So data of pipe gives us the pipe object or pipeline that we created, the model we created, and which that is assigned to the variable pipe. And similarly makers models is a variable which is assigned with makers and models of the data. And similarly as it is saved with as a dictionary, and keys as makers models are saved as a dictionary, keys are the makers and the values are the models of the makers. That's why when we take out the keys it gives us list of makers. So the makers are saved, or the keys are saved to makers. Now the front end part, from here onwards I have created the page. So it's a single page showing the machine learning model. So at first I have created two columns. st.columns is a method in Streamlit which creates the columns of specified number of columns. If we specified 3 here, only 3 without square bracket, without a list, then it will create 3 columns. If we are providing inside a list, then it will allocate the width size of the columns. So here we have created 2 columns with varying width, one of 1 unit and another of 3 units, and between them the gap is very small. That's why gap equal to small as the next parameter, and border we want without border. That's why border equal to false as the third parameter, and vertical alignment equal to top. This is because the inner elements should begin from the top of the column. That's why vertical alignment equal to top. So inside the column 1 I have passed my logo, that is car images / logo.jpg, and set it to a width of 100. So logo is my logo, it's for my purpose to make and to show it beautiful. And inside column 2 a title that is car price predictor. So to see that, no need to see now. If I click on see, the recording will stop. That's why I'm not running it. So I hope you will understand the problem. So next I have created an expander that is speaking about the project. And so about the project is car price predictor is a supervised machine learning model which predicts the price of cars and like this. I have written some text and it is under the expander and Streamlit provides it. Next, the model. I have created a success message named model. It's just to show it beautifully and with an icon, model training icon. And then I have created a container and using with notation I have created a container, and inside the container I have created two columns, col1, col2, again with varying width sizes and with the border equal to true and vertical alignment equal to top. Now under the column 1 is used for input and column 2 is used for output. So inside the column 1 I have given an info status bar with label as input and input icon and 4 input buttons. So again I have created under the column 1 4 columns, 2 columns at first, then below that another 2 columns, and those 2 columns are bordered true. And as here only 2 is written, so the width of the both columns are same, those are not varying from each other. So with input 1 I am using a select box to select the makers. So one maker will be selected and it will be assigned to the maker variable, and in input 2 if maker is selected then model names are shown in input box or select box. So select box gives the model names of the specified maker and it is converted to string in this line. So one thing I want to say that if the data type does not match to pipeline or the model that we pass, then it won't work as we expect. So always remember to convert the data type as per the requirement of the pipeline or the model we built. So I hope you understood what is the reason to convert this model name to string and assign it to the same variable. And in input 3 I am taking mileage, or I am getting the mileage from the user, and the mini variable is equal to 5. That means the minimum mileage is 5 and maximum mileage is 28,56,196. So using a text input I am getting that value, and the text input, if mileage is provided then the mileage is converted to integer. So the next input is nothing but a button, predict price button, and if all the mileage maker model name is available, then it using pandas.data frame I am creating a data frame and saving or assigning it to input data, and this input data is now a data frame. So I am passing that input data to predict function or method of pipeline. So that predict function will predict the price of the car or the data that we provided to the pipeline, and that will be assigned to the prediction variable. And I already told you column 2 is used for output. So to look or to show it more beautiful, I have separated the input and output. So column 2 is used for output, and st.success status bar is used to show the label output and with an icon, output icon. So inside the column 2 I have used a container to show the image of the car so that looks get attracted by the users. That's why I have used this try and accept block to show the images, and thus just to attract people or users to this. And another container inside the same column to show the price of the pipeline predicted. So price of the car. So the value is rounded to 2 decimals and assigned to price variable, and that is shown using info status bar with a currency rupee icon. So then I have created 6 columns inside another container with border equal to false. So in each column I have created button. So one of the first 2 column is used for like button, the second one is a MADI, that's not required now to explain, and the third column is video column where you can watch the complete tutorial of this project from the very beginning to the deployment in Hugging Face spaces. And the fourth column is the repository where these codes are available so that all the developers can use this code and read and study and develop their own projects. And in the 5th column I have used connect, that is to connect with me in the LinkedIn. And in 6th column I have given the HF space link so that the space that I have created the users can use and they also can create their own spaces. This is what I have created. And so to run this, click on Control Tilt and go to the directory car price prediction. Oh, what is there? Here it is, car price prediction. So moving to the car price prediction directory, then to run this file use streamlit run app.py and hit enter.